All right, angle, 7.3a. If two angles are congruent, the triangles are similar. So here on number 1, I'm given an angle. Okay, I have to find the two angles. They did not put parallel lines there on accident. There's a reason that they told me that the lines were parallel lines, because I'm going to do alternate interior angles. Alternate interior angles. So what other angles are congruent in these triangles? What other angles are congruent?
The ones that are touching, E.
Yeah, vertical angles. There it is. Two angles in my triangles are congruent. So since I found that two angles are congruent, I'm going to say, yes, they're similar. And I'll go in order. DCE is similar, one wavy line, to FGE. DCE is similar to FGE. Okay, for notes, I'm just going to do all the odds because we have to get through 17. Well, there's 18 examples, but we're obviously not going to go through all 18 examples. Question number 3. Well, now they give me the degree measurements. The degree measurements are given to me. Obviously, I've got 90 degrees and 39. So it's 180 minus, sorry, let me get this right. Minus 90 equals, 180 minus 90 minus 39. Is the missing angle 51 on this side? Yes, it is. Which means this angle is 39. All three angles, well, two of them are congruent. All three angles are congruent. So yes, triangle. Now I have to go, you can start in any order, but just stay consistent. SYE is similar to triangle WCH. I'm going to do number 5. Okay. These two triangles, I'm going to separate them out because that's what I like to do. $67, $91, and missing. $25, $67. Okay, well, here's the deal. If these are my two triangles, that means I really need this one to be 91. But 67 plus 25 is 92 minus 180. This missing angle is 88. That's not the same as 91. Let's check this triangle, this small triangle, 91 and 67. Let's see what's missing. 91 plus 67 minus 180, 22. Those, no, only one of the angles is congruent. That's not good enough. Not similar. Okay. So that's angle, angle. There's 3 examples. 2 of the angles have to be congruent, and then the triangles are similar. All right, number 7. Okay. Side, side, side. All 3 sides have to be in like a direct proportion. So I need to compare the proper sides. This is easily done because you go from smallest side to biggest side. Obviously, 9 would ideally match up with the other smallest side, 14. So I'm going to put a line there next to 9 and 14. Those 2 sides are congruent. The triangles are flipped upside down. The middle, 13.5, has 2 lines. So that's going to be with 21 because that's the middle size. I'm going in order from smallest to biggest, guys. Lastly, 3 lines for the longest side. So I'm going to compare left triangle over right triangle. My left one over my right one. This is left, this is right. Left and right, LR, left and right. I'm going to make proportions. 9 over 14 is 13.5 over 21 is 20.25 over 31.5. And yes, guys, triangle KNR is similar to triangle DES. Okay. All right, so I'm not going to do 8 because that's an even number. I'm going to go to the back side. Let's do another side, side, side similarity. All right. Same thing. The smallest side on one triangle is going to hopefully be similar. We don't know if they're similar yet. That remains to be seen. The middle size, 7, is going to go with 12. And I'm just looking at the sides and deciding which ones, Then 10 goes with 16. So this is what I'm hoping for. I'm going to write a proportion out. And I'm hoping for 4. Do you want to go left to right again? Left over right? Sure. That's just the same as big over small. Okay, ready? 5 over 4 equals 12 over 7 equals 16 over 10. Well, you guys, we have to figure it out. The best way to figure this out is to divide and see what decimal it becomes. 5 divided by 4, 1.25. That's 5/4. What's 12 over 7? 12 divided by 7, 1.71. Uh-oh. No, it's not equal. So already now I can tell, no, it's not similar. Not by side, 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 not by anything. The proportions make decimals. Those decimals, as you can see, they're not similar. They're not the same. Okay. 11 has a missing side. Oh, 5 something 13. This is a Pythagorean triple. Do you guys know what the missing side is? 5 blank 13. Pythagorean 12. Yep, good memory. So I can do something like 5 over 9 is equal to 12, the legs, over 21.6. I don't even need to talk about the hypotenuse. Let's just see if those two are equal. 5/9, 5 divided by 9, 0.5 repeated, 12 divided by 21.6. Yes, they're both 0.55555. Yay. That means, yes, triangle XYZ is similar to triangle VWR. Okay. Last few. Side angle side. Ready? Okay. The angle has to be in the middle of the two sides that are similar. So if I look at 13 right now, I can see side angle side. The vertical angle is obviously there. So that looks good so far. So now it's a matter of what side matches what with what? What side matches with what other side? Well, look at, I've got a 6 and a 12, a 24 and a 48. Obviously the 6 is going to go with the 24 because they're the shorter sides. 12 goes with 48. So 6 over 24 equals 12 over 48. Yes, it does. Triangle SER is similar to triangle GEF. Okay. Number 15, this will be our last one. All right. I need these parallel lines to create alternate interior angles somewhere. Hoping. So the parallel lines would give me, oh, you see the side angle side, right? On this triangle, side angle side, how it's side angle side. Okay, so on 15, I've got these parallel lines cut by a transversal. Let's have, ooh, M can be P, M and P. Those are corresponding angles with parallel lines. I could do that. I don't need to do alternate interior. Let's do corresponding. Now, 22 obviously matches with 36. 33 matches with 54. Let's write a proportion out. Is 36 over 22 equal to 54 over 33? I don't know. 36 divided by 22. 1.63. 54 divided by 33. 1.63. Yes. Awesome. Yes, side, angle, side. The angle is in the middle of the two sides. Triangle CMP is similar to triangle RPQ. Okay. All right. So your homework is additional practice. Let me write it right here. Additional, let me turn off the recording first. Sorry.